Hey, so I thought I'd make a short video because I had somebody ask me about what I use for soldering after seeing my setup here. And this is a, right here, this is a Metcal soldering station. This is a Hacko 852 hot air station. That's on the side there. This is the bottom. But this is the Metcal stand. See some of the tips in the back. And this is, importantly, the Metcal power supply. This is an older one. They make some newer power supplies, but I've had this for years now, and I got it used even. They're very economical. They're still about $300-400. But they certainly are worth the money, in my opinion. There's no other soldering station that I've used that comes close to the heat delivery capacity of a Metcal. These are only about 40-watt irons. Is what it can supply, but they're instant heat. They are totally instant heat. Nothing. There's nothing else out on the market like it. There's some copies now, but what's interesting, and you'll see here, this is a tip. Let's see if I can zoom in here. You'll see it's coaxial. It's because it's RF. This actually operates at about 13 megahertz. And let's see, there's the numbers on the tip. Whoops. So the 1 means, and these are fixed temperature tips. So that 1 there means that the tip is about 700 degrees, which people are going to say, oh, that's warm. It's actually really not. It's very well controlled temperature. There's nothing else out there that's able to do this sort of temperature control, because the nice thing is, for production, if you're doing anything, you can get lower temperature ones. But for doing any lead-free stuff, I like the higher temperature because you're only sitting on the joint for a little bit. The Metcal is not adjustable. It just the tip temperature is determined by the tip. And the way it works is pretty cool. There's a RF oscillator and amplifier here. This puts out about 45 watts or so at 6 megahertz. Goes through the coaxial cable here. It's an F connector on the back, actually. And then it goes into the tip. And the nice thing about these is how thin the tip is. And even up here, you can start feeling it's a little bit slightly warm. It's maybe 85 or 90 degrees when you put your hand on it right there, which is nice and cool. The moving around with it is real easy. It's not heavy, and most people are going to say, well, hold on, it's not heavy. That means you don't have a good reserve amount of heat in the tip. That's actually not true. The way these work is amazing. They have essentially a resonant circuit in here, ferro-resonant circuit, that when it gets to its what's called its curry point, or its set point, it detunes and it stops absorbing energy. As soon as it gets cooler than that, it starts absorbing energy from the RF. So I don't know what that means in terms of SWR, but I have it turned on right now. I can turn it off here. Let me, you generally shouldn't do this, but okay. So it's cooled down, and it doesn't, because it doesn't have a huge heat reservoir, it doesn't get all that, it doesn't radiate heat down. So if I turn it on, you'll see in about, there you go, just a few seconds, it's up to operating temperature. Very few other irons on the market are like that. There we go. The other nice thing that I have here, I'll show you, is the this guy right here, and this is pretty cool. Let me move this around. So normally this sits in here and you're like, well, okay, it's just a soldering holder. Not exactly. This part in here, if you can see, is actually magnetic. And what it does, this is what's really cool. When you put it in there, the magnetic field detunes it further and keeps it so that it cools off. So right here, it's maybe, instead of being 700 degrees, it'll bring it down to 500 or 550 or so. It'll still melt solder a little bit occasionally in here, but not that much. So when you take it out, immediately the power goes up to it, and within a half second it's at operating temperature. And then you have your connectors in the back here. One of the nice things that comes along with this is there's a, I'll show you right here. This pad that comes on here is pretty useful for being able to take parts out like that. And I'll show you what happens when you do that. Okay, put it back in there. You see the LED comes on there on the Metcal power station. You have to reset it. That's because it goes to protect itself when you remove the tip. But I'll show you a demonstration here. This is a pretty standard tip. This is the small guy. I'll zoom in a little bit so you can see. It's a pretty standard tip. There's also other tips that come with it, and I have a few of them here in the back. Come down here. There you go, and you can see them. I also use the kind of one of my favorite tips for doing anything surface mount is this guy right here. It's a conical tip, and these tips do wear out. So when they stop working, you have to basically throw the tip away. Brand new tip can be upwards of $30. There's some cheaper ones that are available. I've had good luck just going with the Metcal branded ones, but a lot of times you'll get surplus ones. You can get ones that were used elsewhere, and they're still serviceable, at least for hobbyist work. And that's, you know, these last a long while. This tip I've had here for going on about 4 years now. The same thing with this one here that I use all the time. Come on. That tip there, I've had almost the same amount of time. And, you know, I've left the house and left the base station on by chance. So, you know, having the this right here that, you know, lowers the tip temperature when you stick it in there, does wonders to preserve the life of the tip. So let me show you how this works. I got a couple really big pieces of copper here. I'll show you how easy a small tip works on this. And people are going to say, well, you know, this just isn't possible. You'd need a big 100-watt honking iron, and this thing can do that work. So, you know, for the hams that put together the PL259s and stuff like that, this will work for that. I don't think you should use a PL259 ever. But if you have to, this will put it together. It's great for doing work on circuit boards where you have ground planes and things like that. I'll demo some of that here. Okay, so this here you can see is just a regular old duplexer loop. It's actually, I think, from a 220 band pass filter. Well, it's definitely a band pass loop. But I have it just on a little piece of fish paper here to work with. Excuse me. And all I'm going to do is use a little bit of solder to get going here. Make certain my tip's clean. And first I'll show you how easily it reflows the top here. And this is solid copper. Boom. And it's reflowed. This for a small little iron is amazing that it has that kind of ability to do that. So this should come off now. Okay. That's off. And now you're going to say, well, hold on. You do this whole big thing here with the PL250, or that PL259, the end connector, and all this. And yeah, you can. It just takes a minute. I've also used hot air to do this before with like a board preheater, but this will work here because, you know, it's not critical. And that Teflon there is good up to a few hundred degrees above what solder melts at. It's getting ready to reflow. You start seeing this melt here shortly too. There you go, it's starting to melt, starting to wet. It's almost there. Take a look at the other side here. It's starting. There we are. That entire thing is reflowed now, which is very neat. I should be able to just lift it off. There we go. Oh, even this came off. How about that? There we go. All that from a little 40-watt iron. I'll demo some work here in a minute on some other stuff. Okay, so this is a little project I'm working on here for it's eventually going to be surface mount, and it has a CPU on it too. It's a little PIC microcontroller for synchronous to asynchronous converter. Schematic, and I need to add a few control lines here, so I'm going to do that using the Metcal, and make certain I'm on the right port here. So that's the port I need to, and I need to add a few more things off of yeah, this guy here. That guy there is working, and it needs another reset on it. So let's see, that's pin, so I look at it, so that's pin 1, pin 8. Let's see if I can zoom in here. So yeah, we got pin 1, pin 8, yeah. No, wait. We plug it in like this. So yeah, okay. Pin 1 is there. Whoop. Come on. Pin 1, pin 8. So in this case, I have, if I look here, I have pin 1, CTS, going to pin 7 on my chip, which is this guy right here. So 1, 2, 3, 4, 5, 6. So that's pin 7 on the chip. He's there. And pin 10, which is 8, 9, 10, goes over here to pin, let's see, pin 10 comes out and goes up to pin 24 on the pick. So here's the pick. And let's see, 20, 1, 2, 3, 4. Yep, that's there. 1, 2, 3, 4. That's that brown wire. Okay, so that's there. What needs to be put on here is a reset line. And what we're doing is we're using the DTR line going into this input here. We're just tying that to the, through some logic here, to the mClear line, or the reset line. So if this goes low, the chip is held in reset. That gives us a nice hardware ability to reset this from the host, which communicates over a serial port. So I'm just going to use some little white wire wrap wire here. And this has to go off pin 7, which is going to be let's see, so that's 1, 2, 3, 4, 5, 6, 7, 8. So pin 7 is going to be this guy right here. And one of the things I want to demo here is these are kind of cheap proto boards from China. They're not plated through the holes, and they hold up just fine to some of the high heat that this thing generates. There's a lot of concern, oh, I'm using a 700-degree tip temperature, I'm going to lift pads. And that's, I can assure you that's not the case. I mean, if I go here on a, just a regular old pad, and these aren't the best proto boards, but they're cheap, so it doesn't lift the pad at all. It's still, once that cools down, it's still on there. It's not going anywhere. I have lifted pads, but you can lift pads with really any soldering iron if you want to. If you're not quick about it. So okay, so this white, which is pin 7, has to go into pin 13 on this chip right here. And I didn't have smaller ones, so it is what it is. So pin 13 is going to be, I just have to stop and count one. Okay, so that's 8, 9, 10, 11, 12, 13. Okay, so let's see, 8, 9, 10, 11, 12, 13. So 13 is going to be that one. 12 is what the output will go to. There we go. Trim that back up a little bit. $12, $13, $14, $15, $16. Okay, yeah. This wire wrap wire is real nice for doing this because it's silver plated, and it just works wonderfully for that, and it's cheap too. I have much more than I know what to do with here, in various colors. Okay, so now I got to go from 12 to pin 1. Or let's see, or I could go over here to this guy, wherever I want to go, because I got the this is the PIC interface, the ICD interface, so I could go off of pin 1 on that guy if I wanted to too. So we have that. Let me go to 12 now. I'll prep the end of this. Okay. Okay, now we go to pin 1 on this guy, which is right there. And that's pin 1. You can see there's a resistor in there that holds it up from the power. You know, a lot of people say you're not supposed to run your resistors here like this, but it's a prototype board. I got 5 of these and they're all a little bit different, so. Okay, and we now have the reset line. You can see the white from async goes in here, gets level converted here, and goes back over to this guy. And that's all thanks to this little tip right here. And it works really well on surface mount stuff too. I'm able to work on all that. But there was you know, somebody was saying that this will burn up pads, and that's certainly not the case. This is just, in working with it, one of the best soldering irons you can get. I wish more people would get them because they're beautiful if you do any sort of serious rework, or soldering iron work or hobbyist stuff. It's just the superior product. And a lot of people talk about Pace or was it JBC or JCB or whoever. I really, again, prefer this guy because it's you know, it's so much better. So anyways, that's the Metcal, showing some rework here on a board, and why I really prefer the product. So set that there. Yeah, so I'll program that. I got to put a pick in here and program it up, but this is for a little project we're working on, synchronous, asynchronous, and the reason we haven't made circuit boards yet is we're we're not certain that this is 100% functional. So I made up a few of these for our software engineering guys to test with. So anyways, with that, my Metcal soldering iron, and really go out and buy one. If you do any sort of soldering, you're going to love it. Anyways, thanks for watching. This is Brian Fields, amateur radio call sign, W9CR.